ML enthusiast. He'll be talking about leveraging machine learning for game development. Over to you, Fahad.
Is the presentation visible, Pooja?
Yes, yes. Yes, it's visible.
Yes. So, have you ever wondered how these modern games are made? Well, let's explore how. Evening all, I'm Fahad Noushad of Sri Chitra Tirunal College of Engineering, Trivandrum, and I'm here to provide an insight into leveraging machine learning for game development. So, probably you ask, why game development? From the stats by Newzoo in 2020, there are more than 2.7 billion gamers, with 55% of global gamers in Asia Pacific region. And it is expected by the fall of 2023, there will be more than 3 billion gamers worldwide. From the dawn of arcade to the rise of home consoles and PC gaming, the gaming industry quickly grew to rival and outpace film and television. Once mobile gaming took off, the wave of revenue became an ever-growing tsunami. As of 2020, the global gaming industry revenue is set to hit 165 billion US dollar, with a 2.7 billion gamers worldwide today. The charts shown in the slides explore how the industry has changed and grown since the 70s. Machine learning, abbreviated as ML, often comes along with AI, but you don't really know how the stuff works or where it is used. Let's have a dip into ML and then jump off to our topic. Machine learning is a branch of computer science which focuses on the use of data and algorithms to imitate the way humans learn, gradually improving its accuracy. So, as industries grow, the demand for developers skyrocketed, with which methods adopted for game development evolved. Nowadays, designing game scenes are becoming more and more complex. There is an increasing demand on highly skilled game designers, as players expect games to be well crafted and photorealistic. So a novice painter or a graphic designer might set a brush to canvas, aiming to create a stunning sunset landscape, cracking snow-covered peaks reflected in a glassy lake, only to end up with something that looks more like a multicolored inkblot. Well, we have a solution for that. Machine learning technique is a key to that. A machine learning model developed by NVIDIA Research can do just the opposite. It turns rough doodles into photorealistic masterpieces with breathtaking ease. The tool leverages generative adversarial networks, or usually known as GANs, to convert segmentation maps into lifelike images. NVIDIA has also publicly released the source code for the neural network behind GoGAN, making it available for developers to experiment with and build their own applications. So GoGAN allows users to draw their own segmentation maps and manipulate the scene, labeling each segment with labels like sand, sky, sea, or snow. As you can see in the slide, the ink blots that look just like a doodle has been converted into stunning photorealistic images. To experience this, you just need to have a PC with a browser and a stable network connection. Since NVIDIA has launched a web app which is hosted on NVIDIA's GPUs through Amazon Web Services, or you can run the application on any devices powered by NVIDIA RTX GPU. So let's explore what's behind this. This technology is developed using PyTorch, a machine learning framework. The neural network behind GoGAN was trained on 1 million images using NVIDIA DGX1 deep learning system. Despite lacking an understanding on the physical world, GANs can produce convincing results because of their structure as a cooperating pair of networks, a generator and a discriminator. The generator creates images that is present to the discriminator. Trained on real images, the discriminator coaches the generator with pixel by pixel feedback on how to improve the realism of its synthetic images. After training the discriminator knows that real ponds and lakes contain reflections. So the generator learns to create a convincing imitation. The tool also allows users to add style, filters, changing a generated image to adapt the style of a particular painter, or change a daytime scene to a sunset. Now that we've gone through NVIDIA Gauguin's working principle, let me show you a demo. Here you can see me, actually it's me painting. You can see how the art appears on the right side. In a moment, you can see how the stunning photorealistic reflections can be seen. So this is the wonder created by NVIDIA, and these can be made using game development to create stunning environments and stuff like that. So over the years, online multiplayer games like Fortnite, Call of Duty Warzone have exploded in popularity, captivating millions of players across the world. This popularity has also exponentially increased demands on game designers as players expect games to be well crafted and balanced. After all, it's no fun to play a game where a single strategy beats all the rest. In order to create a positive gameplay experience, game designers typically tune the game of a game iteratively. They stress test through thousands of play testing sessions from test users and incorporate feedback and redesign the game. And these steps happen repeatedly until the play testers and game designers are satisfied. This process is not only time consuming, but also imperfect. The more complex the game, the easier it is for subtle flaws to slip through the cracks. When games often have many dozen roles that can be played with dozens of interconnecting mechanics, it makes it more difficult to hit the right balance. This poses a challenge to both product quality and the developer's quality of life. Well, we have a solution. Machine learning techniques offer a possible solution. A ML-based framework developed by Google AI that game developers could use to train game testing agents quickly and efficiently, freeing human testers to focus more on complicated problems. The resulting system requires no machine learning expertise and works with a wide range of popular game genres. It works by training an ML policy which generates actions from the game state on a single game instance in less than an hour. Google AI has also provided an open source library that shows how these techniques may be used in practice. So now let's understand how this Google AI model works. Simply playing the game is most basic form of video game testing. Many serious bugs such as crashing or falling out of the world are easily detectable and fixed. The major challenge is to find the bugs within the vast space of modern game. An effective way of tackling this was by enabling developers to train a group of game testing agents instead of training a single super effective agent playing the entire game from end to end. Each agent could complete tasks of a few minutes, referred to as gameplay loops. Now, bridging the gap between simulation-centric world of video games and data-centric world of ML is one of the most fundamental obstacles in applying machine learning to game development. Instead of asking developers to translate the game state directly into custom low-level ML features, which is too time-consuming, or attempting to learn from raw pixels, which is too much data is required for that. The proposed solution by Google gives developers an efficient, game developer-friendly API that lets them describe their game in terms of core stage that a player perceives and the semantic actions that they can take. As you can see in the slide, the API allows the specification of observations and actions in just a few lines of code. So this API is broad enough to mimic various popular control schemes in games, including first-person shooters, third-person shooters with camera-related controls, racing games, twin-stick shooters, and so on. The technology achieves this by evaluating the game's control scheme and creating a neural network layer that performs specialized processing of the game's observation actions. As you can see in the image, it is the neural network for getting the control schemes of the game. So for this use case, imitation learning, which teaches ML policy by watching professionals play the game, performs effectively. Unlike reinforcement learning, where the agent must find a good policy on its own, imitation learning requires replicating human expert behavior. Since the game developers and testers are experts in their own game, they can quickly demonstrate how to play the game. This approach allows the system to take advantage of video games with most compelling quality and interactivity. From the developer's perspective, providing a demonstration or a correction to the fault behavior in a game is as simple as picking up the controller and starting to play the game. Once they're done, they can put the controller down and watch the ML policy play. The result is a training experience that is real-time, interactive, highly experiential, and very often more than a little fun. So these technologies like GoGAN for game designing, which utilizes GAN approach in machine learning, and machine learning model, which by Google AI for play testing uses imitation learning, making both the game designing and testing phase of the game development both faster and cheaper. These technologies are just a few examples of how machine learning can be implemented in game development. Thank you. So anyone have any questions about?
Fahad,
Yes, sir.
without a GPU, can you execute these programs? Suppose my
Yes,
system contains only a microprocessor. Is it possible to execute this?
yes, sir. The first one which I described, the GoGAN, it has a web-based application. And for executing, usually for machine learning models, we don't execute usually in our own devices. It has its own specialized cloud services for that, like Amazon Web Services and Microsoft Azure, like that.
Okay.
Any questions from the audience?